Inside a shopping mall in China, a small spinning device the size of a dinner plate flicks on, and a full-color, three-dimensional animated character appears to float in the open air above it, visible from every angle, with no screen, no glasses, and no visible support structure holding it up. That is real. It exists. It's already been sold to thousands of paying customers, and the startup behind it says this is only the first step towards something considerably more ambitious. Every figure in this video comes from the company's own confirmed sales data and independent reporting on the underlying science, because a claim this exciting deserves genuine scrutiny rather than just a viral clip. By the end of this video, you'll understand exactly how this device actually creates that floating image, why it isn't quite the same thing as true holography yet, and how close China's researchers have actually gotten to solving the real scientific puzzle standing between this and an actual holographic television. Here's where this story has to start, because you can't understand why a floating 3D image feels so genuinely futuristic without first understanding just how old the technology sitting in your living room actually is. Every television you've ever owned, from a boxy cathode ray tube set to today's razor-thin OLED panel, shares the exact same fundamental limitation. It's a flat, two-dimensional surface displaying a flat, two-dimensional image, an approach to visual display that traces its lineage back more than a century. Here's what engineers have spent decades chasing as the genuine holy grail replacement for that flat-screen approach. A true holographic display, one that doesn't simulate depth through clever 2D tricks the way 3D movies or video games do, but actually reconstructs the physical light waves an object would naturally scatter, letting a viewer walk around a projected image and see it from genuinely different angles, exactly the way they'd see a real object sitting in the room. Here's why the goal has remained stuck in science fiction for so long. Reconstructing real light wavefronts this way is a genuinely brutal computational problem, requiring calculations so complex that, until recently, no computer could process them fast enough to display smooth, real-time video rather than a single static, painstakingly rendered image. Here's the company that's already selling a real working piece of this broader holographic ambition today. DSEE.Lab, a startup based in Nanjing, the capital of China's Jiangsu province, founded by Zhou Quan. Here's the mechanism behind how the company's existing commercial product actually creates its floating image. And it's worth being precise about exactly what this technology is and isn't, because the honest technical answer matters here. According to Zhou Quan's own description of the device, the product is essentially a propeller fitted with hundreds of individually controlled LED lights. And when that propeller spins at high speed, the LEDs rapidly change color and brightness in perfect coordination with the rotation, exploiting a phenomenon called persistence of vision, the same basic visual trick that makes a rapid sequence of still images look like smooth motion in traditional film, to create the illusion of a complete, solid moving picture suspended in the air. Here's the honest technical distinction worth making directly, because it matters for understanding exactly what this device is. This is what engineers specifically call a volumetric fan display, not true wavefront holography in the strict scientific sense, meaning it creates a genuinely convincing illusion of a 3D image floating in space through very fast, precisely coordinated physical spinning and lighting, rather than by actually reconstructing the physical light waves a real object would naturally produce. Think about why that distinction still matters, even though the visual effect looks genuinely impressive either way. A true holographic display could theoretically show a fully solid-seeming 3D scene visible from any angle with real depth parallax as you moved around it, while a spinning LED display creates its floating effect specifically within the circular volume. The propeller physically sweeps through a genuinely different and more constrained underlying mechanism, even when the end result looks remarkably similar to an untrained eye. Here's the number that shows this technology has already reached genuine commercial traction, rather than remaining a lab demonstration. Since the product entered mass production, the company has received approximately 10,000 orders from customers both inside China and internationally, generating sales of roughly 10 million yuan, or about $1.5 million US. Here's the pricing structure that shows this device was built to actually reach real customers, rather than staying a boutique curiosity. The company's naked eye displays come in a range of sizes, priced between 2,000 and 10,000 yuan, roughly $280 to $1,400 depending on the configuration. A genuinely accessible price range for a business or venue looking to install one, rather than a device confined purely to expensive corporate research demonstrations. Here's the current real-world use case these devices are actually being deployed for today, according to the company's own description. They're currently used for advertising displays and exhibitions inside venues like hotels, shopping malls, and airports, creating eye-catching floating product demonstrations or animated brand imagery, rather than functioning as a general-purpose entertainment screen showing arbitrary video content the way a television does. Here's how far this company's ambitions already extend beyond that current advertising use case, though. DSE.Lebe has expanded with branches in the United States, Germany, and Singapore, and separately secured around 10 million yuan in angel investment financing, with Joquan stating directly that his longer-term goal is producing genuinely low-cost holographic video, rather than remaining permanently confined to the advertising and exhibition displays the company currently sells. Here's where the deeper scientific story behind this video's title actually lives, because the real path towards something that could genuinely replace a television requires solving a problem considerably harder than spinning LEDs fast enough to fool the human eye. Here's the research that's specifically attacking that harder, more fundamental problem. Researchers at the University of Shanghai for Science and Technology published a breakthrough in the peer-reviewed journal Advanced Photonics Nexus, introducing a novel method for generating what's called computer-generated holography, the actual computational process needed to calculate and reconstruct genuine light wavefronts for true holographic display, rather than simulating a 3D effect through physical motion the way DSE Labs' existing product does. Here's the specific computational bottleneck this research team was trying to solve. Conventional methods for generating these computer holograms rely on repetitive, computationally exhausting calculations, historically making real-time holographic video display genuinely impractical, since a computer simply couldn't calculate the necessary light wave data fast enough to keep up with smooth, live-motion video. Here's the mechanism behind how the Shanghai team's approach actually reduced that computational burden. Their method uses what's called a split Lohmann lens-based diffraction model, enabling the rapid synthesis of full three-dimensional holograms through a single-step backward propagation calculation, specifically designed to significantly reduce the computational overhead involved while still maintaining genuinely high-quality 3D visualization. Think about why solving that specific computational bottleneck matters so directly to the hologram television question. This entire video is built around a true holographic display capable of showing smooth, real-time video content the way an actual television would need to, depends entirely on a computer being able to calculate those complex wavefront patterns fast enough to keep pace with live motion, exactly the specific technical wall this Shanghai research was aimed directly at breaking down. Before going any further into exactly how far away a genuine holographic television replacement still remains, it's worth pulling back and understanding where the broader global holographic display industry actually stands as of this year, because China's efforts aren't happening in isolation from a much wider international research race. Here's the honest industry-wide assessment from Specialist Technology Reporting covering this exact space in 2026. Companies like Looking Glass Factory have built genuinely practical light field display panels that let users view 3D content without wearing glasses, offering real parallax and depth as a viewer physically moves around the screen, while separate mixed reality headsets like Microsoft's HoloLens have demonstrated persistent 3D objects anchored convincingly in real physical space. Here's the honest limitation that same reporting specifically flagged about both of those categories. Though light field panels, while genuinely impressive, aren't considered true holographic displays in the strictest scientific sense, and headsets solve the 3D display problem by offloading the complexity onto wearable optics and computing hardware, effectively sidestepping the far more difficult underlying challenge of actually projecting light directly into open space the way a true headset-free hologram would need to. Here's the industry's own overall timeline assessment for when a genuine mass-market consumer holographic display might actually arrive. That same 2026. Technology analysis specifically concluded that affordable, compact, content-rich consumer holographic displays are more plausibly a phenomenon of the 2030s, not something already sitting on store shelves today. This is not a story where a single Chinese invention has already quietly solved the entire holy grail problem while the rest of the world wasn't paying attention. This is a genuinely global, multi-front research race, with Chinese companies and universities contributing real, independently verifiable progress on specific pieces of the puzzle, sitting alongside comparable efforts happening simultaneously in the United States, Europe, and elsewhere. Here's the honest concession worth sitting with directly, because credibility matters far more than declaring television obsolete today. DSE.Lab's currently available product, the one already generating real sales and real commercial revenue covered earlier in this video, remains fundamentally a volumetric fan display, rather than true wavefront holography, currently used almost exclusively for advertising and exhibition purposes rather than general home entertainment, and it cannot yet display arbitrary broadcast video content, streaming shows, or the kind of flexible, full-color moving picture a television handles as a matter of course. Here's the second honest limitation worth including directly. The University of Shanghai's genuinely significant computer-generated holography breakthrough remains a peer-reviewed academic research result, demonstrating a faster calculation method, not a finished consumer display product, currently available for purchase, meaning the specific computational bottleneck it addresses represents real, meaningful scientific progress toward an eventual holographic television, rather than evidence that such a device is already sitting in a factory ready for mass production. Think about why combining these two honest caveats actually paints a more accurate, and in some ways more genuinely exciting, picture of where this technology actually stands, rather than a single finished invention that's already replaced the television. What actually exists today is real, working, commercially available technology solving one specific piece of the holographic puzzle, sitting alongside real, peer-reviewed academic research, solving a separate, deeper piece of that same puzzle, with the full combination still genuinely years away from becoming the kind of device you could realistically mount on your living room wall in place of an OLED TV. So here's the full picture, start to finish. Every television ever built shares the same fundamental limitation of displaying a flat, two-dimensional image, a constraint engineers have spent decades trying to escape through genuine holographic display technology capable of reconstructing real light wavefronts rather than simulating depth through visual tricks. DSEE.lab, a Nanjing-based startup, has already built and sold roughly 10,000 units of a genuinely working, commercially successful volumetric fan display using rapidly spinning, precisely coordinated LED lighting to create a convincing floating 3D image currently deployed primarily for advertising and exhibition use rather than general entertainment. Separately, researchers at the University of Shanghai for Science and Technology have published a genuine peer-reviewed breakthrough specifically solving the brutal computational bottleneck that's kept true, real-time holographic video display impractical for years, using a split Lohmann lens-based diffraction model to dramatically reduce the processing overhead involved. And according to the broader industry's own Honest 2026 assessment, a genuinely affordable, content-rich, mass-market holographic display capable of actually replacing your television remains more plausibly a 2030s technology than something already available today. What you're actually looking at in this story is the same multi-decade pattern that eventually produced the flat-screen television itself, which took engineers from the earliest experimental cathode ray tube demonstrations all the way through decades of separate incremental breakthroughs in plasma, LCD, and OLED technology before a genuinely mass-market flat screen finally reached ordinary living rooms. Holograms haven't replaced your television yet, and the honest timeline suggests they won't for a while longer. But for the first time, real, independently verifiable pieces of the actual technology needed to eventually get there already exist, commercially selling in one form and scientifically proven in another. If breakdowns like this, the real science and the real limitations behind China's biggest display technology breakthroughs, are useful to you, hit like and subscribe, because there's more of this coming, including a closer look at what happens the first time someone actually combines a fast, real-time computer-generated holography engine with a genuinely open-air, headset-free display screen. So here's the honest question for the comments. Does knowing the real technology behind that floating LED image change how impressive you find it? Or does the genuine, verified progress on the harder computational holography problem make you more confident? A true holographic TV is actually coming sooner than the 2030s timeline suggests? I read every single one.